Hi, you're watching Chemistry in Action. I'm your host, Ramon Miranda. Last week, we launched our program showing how chemistry fills our day-to-day lives. Today, let's dig deeper into that subject. We hope to come up with a satisfying answer to the question, what is chemistry? For a start, we know that chemistry is a study of matter. So you could say that in chemistry, matter is what matters. We'll continue our discussion on matter after a short break. When we study chemistry, we study the structure, properties, and composition of substances, as in the sample of spring water, which we have here.
The spring water is a sample of matter. It could be a single substance or a mixture of substances. To study it, we can ask these questions. What are the distinguishing properties of this substance? Does this bottle contain only one substance? Are there other substances present? Are they safe? What is this substance made of? What elements compose this substance? In what proportion are they combined? How are they combined? These are the same questions chemists try to answer when analyzing substances. They search for the answers to these questions with the aid of many sensitive scientific instruments. Let's take a look at some of these.
This is the high-performance liquid chromatograph, or HPLC. We use this instrument to determine substances like pesticide residues. So we inject the sample in the injection port. That sample will go through the separation column, out into the detector, and into the graph. So this is an example of peaks that tell us when a component is coming out. So through peaks like this, we can know what are the components coming out and how much we have in the water sample. This instrument is used to determine pollutants like chloride, nitrate, nitrite, or phosphate. And again, the presence of the components we are interested in can be shown in this graph or integrator, also as a peak, similar to what we have at HPLC. This is the Atomic Absorption Spectrophotometer, or AAS. We use this instrument to determine the presence and the amount of metal ions like lead and mercury, which are two of the most common and most frightening pollutants in water.
In the case of our water sample, we can also ask the question, what happens to it over time? Can we mix it with other substances in order to change it into another chemical? To find out, let's do a simple experiment.
Add a piece of calcium carbide or calburo to our water sample. Watch. When you add calcium carbide to water, you get acetylene gas, which is flammable, and calcium hydroxide. Water has been transformed into other substances, one of which can be dangerous. So, watch out. With concrete examples like the one you just saw, you can better explain chemistry to your students.
What is chemistry? In chemistry, we study matter, its composition, its properties, structure, changes. And the laws and principles governing these changes.
Chemistry helps us predict the changes that take place when combining different substances. These changes come in patterns, and governing these patterns are the laws and principles of chemistry.
What contributions can chemistry make to human progress? In what ways does chemistry help solve society's urgent problems? The answers to these questions after an urgent break. The world today has more than 5 billion people. We can only expect this number to increase. How do we continue to feed this growing population? How do we ensure that people live longer and are healthier?
Chemistry plays a very important role in this quest. Fertilizers, pesticides, vaccines, and growth promoters for plants and animals. All these are the fruit of agrochemical research. With these products of chemistry, we have bigger harvests and higher livestock production.
Chemistry not only helps in food production, but also in providing energy for the world.
To do the ordinary as well as the extraordinary, like